Tonight is December the 18th, 2014. I just brought out a Dynaco ST70 I've had for years. I'm going to start using it again. I gave the receiver that I have in here, an old Mac 1700, to my son, and I thought I'd throw it up on the bench and check it out before I hooked it up. Well, I'm glad I did. Let me show you what it's doing. I'm checking one channel at a time. And I'll show you how I diagnose and start this stuff. Okay, I'm looking at the left channel. Of course, it's being into these two load resistors up here. So there's the two wires that come back and hook up to the speakers right here in the back. But anyway, I'm looking at the left channel, and there's what I'm getting. You see that? That is a lot of hum. Okay, I'll show you. If I move it from the left channel to the right channel, I have to go up here and switch this guy. Well, see, I'm getting none. Press the auto button here. That auto. That's the distortion product. It's not as bad as it looks because it's not a one-to-one relationship between the power output and the distortion products. There's our power out right there, 12 watts at 0.2%, 0.235% THD. So it's actually working. This is its voltage across 8 ohm. You can square that, divide it by 8, and you get that. But there it is, 0.2%, 12 watts. Looks good. Move it back to the other side. Switch our load. Bad, bad, bad. Okay, now we've got to know, is it 60 hertz or 120 hertz? If it's 120 hertz, we know it's coming from a full wave rectifier and it's the power supply. If it's 60 hertz, well, it's something else. It's either we're picking it up in the air, which we're not. Well, actually we are, aren't we? Look at that. You know what it is? It's a bad connector right there. Right there. That's where it is, because I just torqued it sideways a little bit. No, you know what I bet it is? I bet it's that female pin in there is probably not pinching the male pin right here properly. Well, let me show you what I did. Okay, I just made it. I just made it bad again. I didn't do this a while ago, but anyway, I want to show you how you determine. This question has come up before. When you have hum, you must determine whether it's 60 hertz or 120 hertz. Well, we can do that real easy. Watch this. Let's turn channel 1 off, and then let's stretch out channel 2. No. I got it wrong. Let's put channel 1 in there. Channel 2 is what I'm looking at. Sync on it, there it is. And then if we look between the distortion products, there it is. There's the hum right there. I know I'm creating it now. I didn't realize that it was just that connector a while ago. I'm glad it is. But this is the hum. Let's suppose that it's solid. There's nothing I can do about it. That I can't make it go away by wiggling. Well, then I can put this particular scope in delta time and measure from one cycle to another cycle, and I get 16.97 milliseconds. And then if I press both of these at the same time, there it is, 58.9 hertz. See it right there? So that's 60 hertz. So that's 60 hertz signal that I'm seeing. It's not 120, so it's not the power supply. Because if it were the power supply, if there was something wrong in here, the power supply would be 120 hertz. Well, I solved my own problem quicker than I thought, which I'm glad. But that is something you have to determine when you see something like what we were just looking at there. if it were constant, darn it, now I can't make it work, can I? I can't make it not work. It's just dirty contacts. Or maybe it needs crimping. There it is. See, if you were to see that, look at what it's also doing up here too. We got 14 watts at 6% THD. So we know that's wrong. We can look at the 14 watts at 6% and say, well, there's something wrong with this. And then we look down here and we see the problem, and that's how we analyze what the problem is. It's a 60 hertz problem, because that's why we measured this. But fortunately, it's just a bad connector problem. So there you go. That's one way to start. I'll do some finish some analysis on this, and it's been a long time since I've checked it out. We'll see how it goes. Okay, well, that was an easy fix, but it's a very common problem that there isn't anyone that's ever dealt with amplifiers that hasn't dealt with loose connectors and the hum associated with it. And I'll tell you, it can be hard to differentiate between 60 hertz and 120 hertz just from listening to it and being completely subjective about it. Well, anyway, I'm looking at the right channel now. Here's its output for what that's worth. What we're mostly interested in is right there, 41.59 watts at 0.5% THD. It's doing really well. That's the right channel. If I raise it, right here I can raise it by tenths of a decibel by lowering. I can raise the output by lowering the attenuation. If I raise it a little bit, see, I get up to 42 watts at 0.8%. I'm driving one channel at a time. So it'll do 42 watts at less than 1% THD. That's the right channel. What I ended up doing actually was tightening this thing up nicely. I got it really tight now, huh? And I used this this type of deoxit cleaner on it. So I've got a nice solid connection on it. I wasn't getting a good ground connection a while ago. Let's go back to the other channel. Let's check it. And there it is, 42 watts at 0.9%. So it's perfect. It's just doing marvelous. Well, this little amp has a couple of really nice 7199s, USA made. Same here, the you know, the green lettering. I got a flashlight here. This may overwhelm it, but we'll see. Yeah. So I got some really nice 7199s. These are Svetlana output tubes and an old GE. Now, some time ago, I changed out. Well, I didn't change out. I got this amplifier a number of years ago, and it did not have the 15.6 ohm resistor in it. If you in the cathode, if you look over here, what they put in it right there, you can see the 15.6 ohm resistor in the cathode, and then they want you to measure 1.56 volts across it. Well, it's going to give you exactly 100 milliamps. I equals E over R. E, 1.56 divided by R, which is 15.6, is 0.1. 100 milliamps. So if you don't have that resistor, you put in a 10 ohm resistor and adjust it to 100 millivolts, to 0.1 volts instead of 0.156. I think I've mentioned this before, but I'll mention it again for someone that hasn't seen some of my videos. That 1.56 is that value because back in the days when these things were made, there was no such thing as alkaline batteries. There was only what we know of now as heavy duty. And a brand new heavy duty battery back in those days, which was a standard D-cell size battery, right out of the box with no load on it across your voltmeter would measure 1.56 volts. You could calibrate your meters with it. So what Dynaco did is they said, well, you know, guys have inaccurate meters, but if they measure a brand new battery, a brand new D-cell size battery, I guess the AA's and AAA's would do the same thing, but I know it's true for the D size. If you measured a D size battery on an old meter like this, and you noted exactly where it was, and you calibrated wherever it was on there to 1.56, and then you adjusted these bias pots here to exactly that same point that you calibrated your meter with that new battery, then you could be assured that you're going to be so darn close to 1.56 that it wouldn't be worth fooling with afterwards, and you'd have the cathode current for the pair set at exactly 100 milliamps. That's why they did it that way. So, for what that's worth. So if you change it to whatever value, just make sure that you're able to adjust it to 100 milliamps. That'd be 50 milliamps per tube. Yeah, I put these test points in right here and put the little labels on. So the amplifier is performing flawlessly. I'm very pleased with that. Let's see. I think that's about it. There's really nothing to fix on it. I do have some nice little covers here. Let's see if I can not electrocute myself, because I do have it on. I guess I'm supposed to say, don't try this at home. Well, that'd be stupid, wouldn't it? That's what television wants us to do. Don't try anything at home. Just sit there and watch your stupid television. Don't ever try anything. Anyway, you know I don't believe in that. But don't get electrocuted either. So I hope this was worth something.